and look through these. I am not going to do every single problem, okay? I don't think it's necessary. I have a lot more in here than we probably need to do. I'm going to make sure you guys have, because remember, this is really review from last year, okay? And from what I gathered from you guys last time we were in class, I think you guys were kind of getting, you remembered sine, cosine, and tangent. We added the new 3 to it. Hello, Amy. So I don't feel we need to do every single little example to exhaustion, okay? We're going to make sure you understand how to set this up. I'm going to do one all the way through on this section and maybe set up a second one just to make sure you're okay. All right. And my goal is to get through that section, the trig 30, 60, 90 section, and this section right here. Okay. And that's the goal for the day. All right. We will pick up some of, maybe it might only be one in that section. Can I help you, sir? Oh, you're stealing my phone. You know, we've got that on the iPads too somewhere probably. Oh, they're both, of course. None of the iPads ever get plugged in. I don't understand that. Does that happen at your house too, where the tablet doesn't get plugged in? Okay, I don't understand that. So the upside is that means that the children can't play it and have more screen time. So that sometimes kind of works for us. Sometimes they scream and scream and scream and want it, and so I'll give it to them and it's got like 20%. And then I'm like, just let it die. Then they have to get off, right? It does, but I'm glad it happens at Ariana's house too. So that's good. Good to know that the Ballards aren't the only ones where the tablets die all the time and never get plugged in. It's always the day I really need it to have it for them, right? I do let it die. I do let it die. And then there's a lot, you know, in this house now. Happens at grandma's house all the time. Always when you're at grandma's house and you don't have your cord with you, right? I was looking through my desk at work because I was in there this week. I actually have like the iPhone, the old tablet cord that was like the longer like Apple cord was in there. I'm like, oh, I think I can throw this one out now. We don't use it anymore. All right. So let's get going with our trig. Okay. So that way we can get through the examples we need to. And the quicker we get through them, the quicker we're out, right? So let theta be an acute angle, find the other 5 values. So here's this, when we're looking at these, okay, we are going to, first thing I look at is what's the reciprocal, okay, because I get that one for free. I don't have to think about it. I just know I'm going to flip the reciprocal. So can you guys tell me from what you remember when we were in class on Wednesday, what's the reciprocal of sine? Can you tell that to me in the chat? You can use the abbreviation for it. Scroll back up, right? It's back up further, or flip back up in your notes. I guess you can't scroll your notes. All right, awesome. It's cosecant. So all I have to do for that one is I have to write down cosecant of theta equals 7/4. That's a 7. Okay, so I got 1 for sure. So I got 2 out of the 6 right now. So I need to figure out what my other ones are. I am a very visual person. I draw my triangle. Okay, so I need to visualize this on my triangle. Here's my right angle. I'm going to choose an angle to be theta. Okay, I'm even going to go as far as I know that across from the right angle is the hypotenuse, across from the theta is the opposite, and next to the theta, or whatever's left over at that point, has to be my adjacent. Okay. So can you tell me for sine, what is the ratio? Is it, and I want you to use the words opposite, adjacent, hypotenuse. So what am I looking at? What divided by what? Tell me in the chat. What divided by what for sine? I appreciate the word divided by, and although Angelica, nice job typing all that out. You were quick, faster than everybody else. And then Itzel just uses O and H like Mrs. Ballard would have. Nice work. Nice work. Okay, opposite and hypotenuse. You've got that down. So what I'm going to do is I'm going to label, and notice I just use O and H there. That's a notation to myself. Okay. I'm going to label my opposite leg with a 4, my hypotenuse with a 7. Okay. I need to figure out my third side. Okay. Who's our friend when it comes to right triangles and trying to figure out the third side? What do I have to do here? to get that third side. We did this on Wednesday. So what do I have to do? It's a nice mathematician, gentlemen. Mrs. Ballard really likes him. Oh, Angelica, you're a girl after my own heart. Oh, Valerie too. Okay, nice work, ladies. Okay, so we're gonna use the Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared. I like how we pivoted and aren't using a squared plus b squared plus c squared because Mrs. Ballard doesn't like it. Good job, ladies. All right, so I'm gonna use, I have a question mark there. I don't care what the variable is you use. Okay, you can put an X, you can put a Q, I don't care. Pick whatever letter you like. I'm using the question mark plus X, or plus not X squared, 4 squared, because those are my legs, equals 7 squared. So I've got question mark squared equals, not equals, plus 16 equals 49. Question mark squared equals, let's see, 16 minus 49, is that 33? Double check my arithmetic. It's always a good idea. All right, I'm going to take the square root of both sides. Do not need to do a plus minus because we're talking geometry. Okay, so I know that my question mark side is the square root of 33. So I now have my adjacent, and I can go through my other 4 ratios. Okay, so I'm going to do cosine next. Can you tell me what's cosine? And I'm talking like opposite, adjacent, hypotenuse. So what's the cosine ratio? Tell me in the chat, and I want to hear from everybody because I'm still not hearing from everybody. I got a lot of people here, and I'm only hearing from about half of you right now. Remember, you do get points for putting in the chat. Oh, and a lot more of us abbreviated. Oh, we didn't do letters. Were we anticipating me saying that? Because you guys did that pretty quick. We're playing the anticipate what Mrs. Ballard's going to ask next game. All right, so adjacent is the square root of 33, and hypotenuse was 7. Which is the reciprocal of cosine? Which ratio is the reciprocal of cosine? Can you tell me that in the chat? Because that's what I would do next. I do the function and its reciprocal. Function and its reciprocal. I want to see everybody, make sure we're all paying attention. Still only got about a half of you. There we go. Okay. So the reciprocal is secant of theta equals, and then we're going to just flip the reciprocal. And in this case, I'm not going to do number 10, so you can write there if you need to. We're going to rationalize just like we did last week or earlier this week, and I get 7 squared of 33. Square root of 33 times square root of 33 is just 33. That's why we take the shortcut, right? Because whatchamacallit, because we don't want to multiply out 33 and then take the square root of it. That's ridiculous. Okay. All right, we got one more. We got to find tangent still. All right, so what's tangent in the or opposite, adjacent, hypotenuse? What do I have to do for tangent? What divided by what? I want to give everybody a chance. Make sure we're participating. All right, opposite over adjacent. So I'm going to go opposite is 4, adjacent is square root of 33. And I know I need to rationalize that, but before I do that, I am going to flip and do the cotangent, which is the square root of 33 over 4, because then I don't have to rationalize twice on this. That's because sometimes we do that. We'd use the wrong one, and then we end up rationalizing twice, which is way more work. All right, I'm going to do the square root of 33. So we've got 4 square root of 33 over 33. Okay, so hopefully not too bad. All right, there's a few of those in the homework for tonight. I'm not going to do 11 completely. I just want to set up the triangle with you one more time, okay? Because I think that you can, hopefully, the ratios are really no different than what we were doing on Wednesday. All right, so let's set up the triangle. So again, I got my right angle, I've got my theta. I'm always going to say across from the hypotenuse, or the right angle is the hypotenuse, across from wherever I choose is the theta is opposite, and then my other one's adjacent. And I don't always have to draw it tilted that way. I could draw it this way if I wanted. I could draw it this way if I wanted. I don't know. I usually pick one way and stick with it. But some years I go one way, some years I go the other. Just depends. All right. Cosine. In cosine, what is the ratio? What divided by what for cosine? What divided by what for cosine? All right, adjacent divided by hypotenuse. Good. So that means it's adjacent over hypotenuse. Adjacent would be 3, hypotenuse would be 8. I'm not going to do it, but how would we get the question mark? What would we have to use? So who's our friend when we have a right triangle to solve for? My favorite equation. I didn't say it's my favorite equation. I just said it was my favorite mathematician. All right, so I've got a few Pythagorean theorems, and I've got a leg squared plus leg squared equals hypotenuse squared a couple of times. My favorite mathematician, right? Don't tell my husband. Okay. I'll have to see if I know I have the heart poster somewhere. I don't know if it's still up in my room or not, but it usually is there. All right, so we would use the Pythagorean theorem, and then we'll do the same thing we did on example 9. All right, I'm not going to go through it because I want to make sure it's Friday. We want to get out of here early, right? So hopefully that's enough to get you going on those, okay? All right, this is more of a kind of a rehash. We're going to fill in these tables and kind of remember our ratios. I know that the majority of you, I think, had Mrs. Rondeau last year, right? I think. I know my 11th graders didn't, okay? But the majority of you had Mrs. Rondeau. Last year when we went into pandemic teaching, Mrs. Rondeau and I team taught our trig classes for a while. It was fun. But so I kind of learned something from her, but I don't remember it. Okay, so this is the thing where she talks about Zach and Cody, the twins, and the mama bear, the papa bear, and the baby bear. That's what we're going to do. Only I'm going to put the Mrs. Ballard formula spin on it because Mrs. Ballard likes formulas. Okay, so I don't care which way you do it as long as you're showing me your work, right? Okay, so that's up to you. And if you didn't have Mrs. Rondeau and don't know what I'm talking about, you should have done this in geometry, okay? So, but I know it's few and far between because I know we've got mostly sophomores. So I was actually looking at that today. So, all right. So all we're going to do first of all is just look at these triangles and just write down the ratios for that are going to fill in the blanks. There's some really interesting patterns in these tables. We're not going to look at them all today. We're going to probably come back to that when we hit unit circle and kind of look at the patterns, but I might point one or two of them out here in a few minutes. Okay. So tangent. So they want me to find the tangent of 30. So I'm going to go to 30 as my reference angle. Can you guys tell me what's on the opposite of 30? What number is on the opposite of 30? Okay, good job. We've got a 1 there. Perfect. Okay, and then the adjacent would be square root of 3, which I would have to rationalize. And if you haven't figured this out yet, we're going to have to rationalize 5 million times during this unit. Okay, that's just an estimate of how many times we're going to have to rationalize. So you just got to get used to it. And we pretty much do the denominator in our heads. Okay, so that's 3 square root of 3 over 3. Okay, let's go down here and deal with the cotangent while we're doing this. Cotangent means I would flip the reciprocal on this piece right here. So when I flip that reciprocal, I would just get square root of 3 over 1 or just square root of 3. Okay, now I am going to look at 45 and the cosine of 45. It doesn't matter which angle you pick because they're both got the same ratio. Cosine is opposite over hypotenuse. So I can see that my opposite of this is 1. Can you guys tell me what is on the hypotenuse? What number's on the hypotenuse? Square root is SQRT when you abbreviate it. Okay, square root of 2. We got square root of 2, and we rationalize it, so we get square root of 2 over 2. Interesting thing here, look at this. Those turned out to be the same. Both the sine and the cosine of 45 are square root of 2 over 2, okay? I am, however, going to pick on this one here to do the flip for the cosine of, or the secant of 45. So it would be square root of 2 over 1, or just square root of 2, and interestingly enough, these are the same again, okay? So it's an interesting relationship right there, which we will see more of in the coming weeks. All right. All right, last one we got to deal with is 60. So 60 is here. What's on my opposite on 60? Let me erase this one. What's my opposite on 60? Okay, square root of 3. So square root of 3 over my hypotenuse 2. There isn't any simplifying there. I'm going to flip the reciprocal for cosecant, so it'd be 2 over square root of 3, and we're going to rationalize it. So you got 2 square root of 3 over 3. And again, there are more patterns than the 2 I pointed out, but we will examine those a little bit further on down the line. Okay. What we're going to use this for is our special right triangles. So there's 2 sets of special right triangles, the 45, 45, 90, and the 30, 60, 90. Actually, I'm going to come back up here and kind of use these triangles so we don't have to rewrite them. I'm going to label them a little bit differently than opposite, adjacent, and hypotenuse. Okay. So, and again, you can use Mama Bear, Baby Bear, Papa Bear, and Zach and Cody if you like. So across from the 30 is what we call the short leg. So it has to be across from the 30. Across from the 60 is what we call the long leg, and this is still the hypotenuse. On the 45, 45, 90, we have a leg and a leg because we know that they are equal. It's an isosceles triangle, and this is the hypotenuse. All right, so my 2 formulas, 45, 45, 90. We get that the hypotenuse equals the leg times square root of 2. The way I remember that is this one with the square root of 2 has the 2 angles that are the same. It might not be a good way to remember it, and Zach and Cody might be better, but that's the way I remember it. Okay. Then we've got our 30, 60, 90, and our 30, 60, 90 has 2 formulas. The hypotenuse equals the short times 2, and the long equals the short times square root of 3. I know that it's square root of 3 because it's the one they want the angles where they have the multiples of 3, 30, 60. Okay. Again, not a great way to do it probably, but or a great easy way to remember it, but it worked. This has worked for me for years. Okay. On the 30, 60, 90, you have to have the short leg. So if you don't have the short leg, you have to solve for it. All right. So I would like to go through probably all 5 of these examples. All right, because this is important stuff, and this is a huge connection between right triangle trig and where we're going to take it with the unit circle in the next couple of weeks. Okay. All right. So I have 30 here. I know that this is the. I'm going to zoom in because that's probably too small for you guys. I'm sorry. Don't do that. Now it's going crazy. There we go. Okay. Hopefully that's better. Sometimes I forget, but I need to zoom in for you guys because your screens are smaller. All right. So I'm going to, I know that this is the short leg. Okay. So what's X on? What do we call that leg that X is on? Can you tell me in the chat? So I talked for a while. It's time for you guys to help me out. All right. That's our long leg, right? Okay, so I only have information about the hypotenuse. So I know by my formulas, in order to get the long leg, I need the short leg. So I am going to use my hypotenuse formula to solve for the short leg first. So I know that my hypotenuse is 8 equals the short leg, I guess I will call that y since they didn't label it, times 2. I just plugged it into the formula. I got to divide by 2, so 8 divided by 2 is 4. So I know that my short leg is equal to 4. Okay, let's do the long leg. So long leg is x equals, and all I'm literally doing is plugging into this formula. So short times radical 3. My short is 4 times square root of 3. Done. Not so bad. Okay. And likely for your test on this year, you will get to have the formulas in front of you. Okay. All right. Let's take a look at 14. So 14 we can identify as a 45, 45, 90. What do we know about the legs of a 45, 45, 90? Can you tell me in the chat? What do we know about the legs? Can you tell me about the legs in a 45, 45, 90? What did we say up here? Okay, good. And I know one of them isn't labeled on this one. They're twins. I will let Mrs. Rondo know that the twins live. So they're equal. Good job, you guys. Okay. That will make her day and make her smile, okay? I will text that to her as soon as we're done with class. All right. So technically these are both x's, aren't they? Okay. So all I'm going to do is plop this into the 45, 45, 90 formula. So hypotenuse equals leg times square root of 2. So my hypotenuse is 6 equals my leg times square root of 2. All right. I got to get that square root of 2 as a number. It just looks weird. I got to get that to the other side. We've got 6 divided by square root of 2 equals x. Okay, what do I need to do to the denominator? Can you guys tell me? I'm not allowed to leave it like that. What's the process called? Want to make sure we get a lot of people this time because I didn't get as many on my equal to question. All right, we do need to rationalize. So I'm going to multiply top and bottom by the square root of 2. So I get 6 square root of 2 over 2. Here's where you have to be careful. Do not write down what I'm going to do first, okay? You cannot do this, okay? Square root of 2 is like 1 point something. It's not equal to 2, all right? So I can only cross things out when they're equal, so do not do that. That's the bad thing to do, okay? All right, 2 goes into 6 3 times, so it's 3 square root of 2 equals x. I like to say insides with insides, outsides with outsides, okay? They're in 2 different groups. And that's it, we only had to find x, right? All right, we're gonna redeem ourselves on my last question where like I had 3 people answer. Tell me what x equals in 15, please. So tell me what x equals in 15. Whatever Andy's doing is hilarious right now because he's laughing. Nobody knows what x equals? There we go, we got one. Hopefully it was just a delay. Here they all come. Keep coming. All right, so x equals 13. So now I need to do, I'm going to use the formula, right? So my hypotenuse equals my leg times square root of 2. Easy peasy, didn't even have extra work to do, right? All right, let's do number 16. All right, so I have 60 degrees and I have 4 across from 60 degrees. So which leg is the number on? Can you tell me what leg the number is on in the chat, please? All right, nice work. It is on the long leg. And it doesn't hurt if you need to label it in there, label it in there. Okay, so I need to find the short before I can find the hypotenuse. So I'm going to go 4 equals the short times square root of 3. Okay, so I am going to divide by the square root of 3. This one's ugly. 4 divided by square root of 3, I'm going to leave some space, equals x. I know I need to rationalize it. So I get x equals 4 square root of 3 over square root of 3 times square root of 3 is 3. That's my x. Isn't that lovely? Check this out. Now I have to take this guy, and in order to get the hypotenuse equals short times 2. So my hypotenuse is 8 square root of 3 over 2. Oh, sorry, over 3, not 2. That's probably on this particular type of problem as ugly as it would get. Okay, I still want to do 17 because I want you to see the one with the radical on it. Okay. All right, so the number is on which side of the triangle in 17? Can you tell me? Which side of the triangle is the number on in 17? Perfect, it's on the hypotenuse. Okay, which one do I have to get? What do I have to get first? So can I get the long leg or the short leg from the hypotenuse? Can you tell me that in the chat? All right, so we can get the short leg from the hypotenuse. So I'm going to do the long leg equals the short leg, which is the y is the short, okay, times 2. So I'm going to divide by 2. So that when I divide by 2, I just get square root of 3 equals y. If you need to label it, you can. And then in order to get x, x is the long leg times the short leg, or equals the short leg times square root of 3. So in this case, my long leg is just 3. Give you about 30 seconds there. And then we're going to look at that last set. And this is the last set is where you possibly need some Desmos. And I'm probably only going to do maybe 1 out of the last set. And then on the next round of notes, we might start with 1 out of that set. But I think 1 will be enough to get you going. Okay, we're going to skip 18. I'm probably not even going to come back to 18. If I come back to one, it'll be one of the others because 18's got a 45 in it, and we just did that. We're going to do 19. It says that we're supposed to solve for the given measurements. Personally, on a test, I'm probably not going to have you solve for the angles. I'm going to refresh your memory on how to do that in case WebAssign asks for it. But if they don't ask for it, then I'm not super worried about it. Okay. So I have my triangle. I'm going to put my 32 where it belongs in angle A. I'm going to put 10 on side B there. And we're back into opposite hypotenuse adjacent. Okay. So my A is on the opposite leg. My C is on the hypotenuse, and my 10 is on the adjacent. I know it's crazy because we got 2 A's now. Okay. So what I want to do is I want to solve for both the A and the C. So I need to identify which ratio I have. So it's kind of the same, it's a different twist on sine, cosine, and tangent. Okay. I'm going to use the hypotenuse. If I want to solve for side A, that means I have opposite and adjacent. Which trig ratio is opposite and adjacent? Can you tell me that in the chat? So I'm looking for the trig ratio that's opposite over adjacent. All right, that is in fact tangent. So tangent of 32 equals, and I'm going to use the A because that's what they labeled it as, A over 10. I totally forgot to solve for the third angle. I'll do that in a minute. All right, so I am going to move that 10 to the other side by multiplying, and we just got out of that log unit, right? This is just like log of something. It's a decimal point number, all right? So if we've got we're writing the decimal point number as tangent to 32, and we'll figure out the decimal point with our calculator, okay? So if I asked for exact value, you would stop there. Now, there is a little bit of a catch in your calculator, okay? You have to make sure it's in the right angle mode. So I'm going to come over here. I need to get Desmos out. Okay. Desmos is here. Graphing calculator. All right, we had 10 times the tangent of 32. Okay, gave us a nice number. But that number would get marked wrong. WebAssign wouldn't take it. It would say, hey, that's wrong. Okay. We're going to get into this, and it'll probably be late next week when we get into it. There's actually two different types of angles we use. We use angles that are measured in degrees and angles that are measured in radians. Desmos defaults to radians, okay? So in order to, if you're on a triangle, you want it to be in degrees. Look at what happens. Oh, of course it doesn't happen when I do it for demo purposes. Okay, I'm going to click on degrees. Watch this right here, okay? So in radians, 6.6, degrees, 6.2. Okay, so there is a difference. It's not a slight difference. It seems like a slight difference, but there is a difference, okay? And depending upon your angle, that difference could get bigger or smaller. So we would write down, again, always 3 decimal places, okay? 6.249, because we want to round up. So 6.249 for that A. Okay. All right, let's get the C, and then I'll go back and we'll refresh our memories on how to figure out angle B, okay, which hopefully you already know how to do. I'm going to do this one in a different color. So I want to find H. So I have I want to find C, which is on the hypotenuse. So I have adjacent and hypotenuse. What ratio is that? Can you guys tell me? What ratio is adjacent and hypotenuse? Remember to participate, get it in there so I know you're still paying attention. All right, so we've got the cosine, and I write the angle measure of 32 equals the adjacent 10 over the hypotenuse C. And notice this time it's different because my variable's in the denominator versus the numerator. All right, so we've done this before, okay? But you just have one extra step in here to get the variable by itself. So I am under division, which means to get the C to the other side, I'm going to multiply. And then I'm going to take the cosine and divide it to the other side. So C equals 10 divided by cosine of 32. And then we're going to go find the decimal point in Desmos. Okay. So let's see here. 10, come on. 10 divided by cosine of 32. Always double check. Am I in degree mode? I am. So 11.792. 11.792. All right, there's one more thing that we need to deal with, and that's angle B. So we haven't figured out the measure of that angle. And the reason I don't care is because this is a way geometry thing, like 7th grade geometry, okay? In fact, my daughter was taking a test on it today. I couldn't believe I looked at the geometry she was doing. I'm like, I taught this to my freshmen 20 years ago. So it definitely has shifted. All right. So how many degrees are in a triangle? Do you all remember that? Tell me how many degrees in a triangle. All right. You've got it, 180. Now, my daughter's not a teenager yet, so I know you're lazier than she is, okay? Because we want to do the least amount of work possible, right? Right now, she would add up 32 and 90 and then subtract it from 180, okay? I'm much lazier than that. I know that if this is already 90, that the other two have to be 90 when I add them up, right? So I'm going to say the measure of angle B equals 90 minus 32. Let's see. So that's going to be 8 there, right? And then we've got it 8 minus 3, 58. Am I right? 58 degrees, double check my work. Okay, thank you, Matthew. All right. That's what, again, I don't know if WebAssign is going to ask you for it or not. It's an old thing. So if they ask you for it, that's how you do it. Okay? All right, that's where I'm going to stop today. Do we need a joke? I haven't done the joke all day. I forgot to do it with my BC class this morning. We were too busy doing progress checks, getting ready for a test. Let's do a joke. I think it's time. And then don't forget, we have Kahoot in like an hour, right? If you want to come do Beauty and the Beast Kahoot with us today. All right, let's see. I need to do Flipgrid. Andy will still do jokes when we go back to hybrid learning. He's already planning his jokes. Okay, here we go. This is it. Let me get it going the right way now. Tab. And don't, oh, I've had some of you go away. If you're an 11th grader, please do not leave on me, okay? Because I got to talk to 11th graders before we all leave, okay? I'm sorry.
I was going to tell a triangle joke, but it was obtuse. And I'll be here all week because I live here.
Okay. All right, you guys. You have a homework assignment. I know you know where to find it. Okay, so go work on homework. That's the last part of it. Make sure you get all the stuff that's due by 5 done. Don't leave on me if you're an 11th grader. I need my 11th graders to hang out, okay? Because we got to talk about next week, all right? So hang out if you're an 11th grader. Of course, Jose left on me. All right, I'm going to stop this thing. Bye, Matthew. Have a good day.